Welcome to another amazing video of trigonometry. In this video, we're going to talk about exact trig values, fully explained so you understand them. So let's do a quick recap of what we know about trigonometry so far. So if we let theta be an angle drawn in standard position and let there be a circle centered at 0, 0, the terminal side of that angle will intersect that circle at a point, x, y, which I have shown here in the picture. Now, what we know in this scenario is a couple things. Well, first off, the height of that point, the vertical displacement, is your y coordinate. The horizontal displacement of that point is your x coordinate. And the distance from the point to the origin is the radius. In fact, that's true for any point on the circle. So that's what makes this a very specific x and a very specific y. And there is the point theta, or excuse me, the angle theta that led us to that terminal ray, which led us to that point. Now, a couple things we know. Because I just drew a triangle, we know through Pythagorean's theorem that a squared plus b squared equals c squared. Therefore, x squared plus y squared, those are my legs, equals the hypotenuse, which is the radius, squared. And of course, I could solve for r by taking the square root of both sides. Therefore, r equals the square root of x squared plus y squared. Okay, all awesome information. But now comes the trigonometry. Sine of that angle is the y coordinate of that point, the vertical displacement divided by the radius. Nice, awesome, easy. And if you're on the unit circle where the radius is 1, well then that becomes even easier math because y divided by 1 is y. Cosine of that angle theta is the horizontal displacement of that point. That's the x divided by the radius. That's awesome. And tangent of that angle is the slope of this ray. It's the slope of that ray. First and foremost, that's what tangent is. It's the slope of the terminal ray. But how do you find slope? Rise over run. The rise is the vertical displacement y, and the run is the horizontal displacement x. So the formula for tangent of an angle is y divided by x. All right, this is awesome. This is all stuff that we already know. Now we just want to kind of expand on this. Now, the other information that we know, and this might be from geometry class, is that sine, cosine, and tangent in terms of geometry, sine is opposite side of an angle divided by hypotenuse, cosine is the adjacent divided by the hypotenuse, and tangent is the opposite of the adjacent. That's what you learn in geometry class. But again, if you go back here, that is actually still true. The vertical displacement is the opposite side, and the radius is the hypotenuse. The x is the adjacent side, the radius is the hypotenuse, so it's not different than what you've already learned. Keep that in mind. So at the end of the day, the mystery, the treasure hunt is trying to find this point right here, x comma y. To find the x, we need cosine. To find the y, we need sine. And then we can also use tangent to understand the slope of that terminal ray. All right, let's... Well, we already looked at the picture. We don't need to look at it again. But let's look at an example real quick here. So if I have an angle that measures 136 degrees and I have a circle, I obviously land at a point. That point is x. That point is y. Okay. Now, before I do anything, I need to know the radius of this circle. So let's just say the radius of this circle is 8. Okay, so how do I find that point? Well, it's really easy. We know that sine of the angle, 136 degrees, equals the y value divided by the radius. Therefore, if I multiply 8 to the other side, 8 times sine of 136 degrees is my y coordinate. Done. Easy. What's my x coordinate? Well, cosine of 136 degrees is the x coordinate divided by the radius 8. Multiply the 8 to the other side, and I get my x coordinate. So those are the exact values of my x and my y coordinate. And the only other value that is not the x or the y, but it's tangent. Tangent is the slope. So what's the slope of this beautiful terminal ray right here? Well, tangent of 136 degrees is that slope, and that would be the slope. So what is the exact value of the slope of that ray? Tangent of 136 degrees. Now, of course, if I want to get some approximations, I could go and grab my calculator. Now, we do have to be careful because there's two ways to measure angles, radians or degrees. Since this problem is in degrees, I need to put my calculator in degree mode. So if we hit the mode button and make sure that the line for radian or degree is selected to be degree, and then the math becomes pretty simple. 8 times, for the y coordinate, we'll do the y coordinate first. 8 times sine of 136 degrees is about 5.557. 8 times cosine of 136 degrees is about negative 5.75. Again, I'm in quadrant 2, so it makes sense that the x is negative. And the tangent, well, not parenthesis, tangent of 136 degrees, the slope of that line is about negative 0.966. So it makes sense because that line is clearly negative. And that's it. That's your slope. Easy. Okay. All very, very simple stuff. Okay. But here's the deal. Actually, let me go back here for 1 second. Notice that I did get the exact values written as 8 times sine of 136 degrees and 8 times cosine of 136 degrees. But, you know, if I want to, you know, kind of put some numbers there, I got to use decimals, right? They're irrational numbers. The result of those two values are irrational values for what that x and that y are. They're numbers that cannot be made into a fraction. However, there are a couple angles where we actually don't need our calculator at all. I don't need the calculator to tell me what sine and cosine are. There's only a few of them, so let's take a look at it. The first is 45 degrees. I will not need my calculator to understand 45 degrees. Let's talk about why. So first off, 45 degrees is an angle that leads me to this point. That point is x comma y. Okay, this is awesome. So if I want to find the y coordinate, I know that sine of 45 degrees equals the y divided by the radius. Now let's assume we're on the unit circle. It's going to make just the math a little bit easier. But that means my radius is 1. If the radius was anything other than 1, you just got to multiply it over. Not too difficult. So basically, at the end of the day, I know that sine of 45 degrees equals y. And cosine of 45 degrees is my x coordinate divided by the radius, which again is 1, so don't really have to worry about it. So cosine of 45 degrees equals x. Now, why do I not need a calculator for 45 degrees? Now, for the previous problem, 136 degrees, I definitely needed a calculator. Why do I not need a calculator here? Because if I draw this triangle where the vertical displacement is the y, the horizontal displacement is the x, I have a very special triangle. I have a 45, 45, 90 degree triangle, and that's a very special triangle that we know the connection between the sides. Here it is. This is something you might remember from geometry class. In a 45, 45, 90 degree triangle, we have our two legs that are identical, so they're both the same. So that's going to help me understand that x and y are the same thing. So what I get for one, I better get for the other. And I also know that the hypotenuse is x times radical 2. Now, why do I not need a calculator to find x and y in that previous problem? Because in the unit circle, the hypotenuse is the radius, which is 1. Which means that x times radical 2 equals 1, because that's my hypotenuse, that's my radius. Divide both sides by radical 2, and I get x equals 1 over radical 2, which means, and again, I don't like leaving radicals in the square roots. We're going to multiply top and bottom by radical 2 to rationalize the denominator, and we get radical 2 over 2. So this side down here is radical 2 over 2. This side over here is also radical 2 over 2. So going back to my picture, since I have a right triangle, a 45, 45, 90 right triangle, I don't need sine of 45 degrees to help me here because I already know that the two legs are both radical 2 over 2. That means the vertical displacement and the horizontal displacement are both radical 2 over 2. So what is my missing point? Radical 2 over 2, comma, radical 2 over 2. I don't need the calculator to tell me that because it's one of these special triangles. I know the exact answer without needing my calculator. Now, if you want to, kind of make sure that you believe me on this, you could definitely use the calculator to check your work. Sine of 45 degrees is 0.707, but again, that's not an exact answer. That's a decimal, that's irrational. But because I understand these special triangles, the square root of 2, make sure you close it or move outside of the parenthesis, divided by 2 is 0.707. Same thing with cosine of 45 degrees. It's that same value. What about tangent real quick? Well, let's actually try to do it without the calculator very quickly. So what is tangent? Well, that's a terrible handwriting there. Tangent of 45 degrees. Well, that is my y, it's the slope, right? Which is my y divided by my x. So if I know my y is radical 2 over 2, I know my x is radical 2 over 2, well, what happens when you divide two numbers are the same? You get 1. So the slope of this ray right here is a beautiful, perfect 1, and I could use my calculator to confirm that if I wanted to. There it is, 1. So this is pretty cool, this is pretty awesome, this is pretty neat, But again, I can only figure out these exact values without my calculator in one of these special triangles like this one right here. So hopefully that problem made a lot of sense. Even though you could use your calculator, remember how much I love exact answers. These are the answers I would expect for a 45 degrees. All right, another one of these really cool angles is 30 degrees. 30 degrees is an angle that takes me to this point. And let's assume right now that I'm on the unit circle with the radius of 1. And I said, okay, sine of 30 degrees equals y over 1, which is, well, just y. And cosine of 30 degrees equals x over 1, which is just x. So, okay, well, I know x, I know y. Instantly, cosine of 30 degrees is y, cosine of 30 degrees is, sine of 30 degrees is y, cosine of 30 degrees is x. But again, I want to emphasize why I don't need to go to a calculator for this problem, because this is a special triangle. I have my horizontal displacement, that's my x, my vertical displacement, that's my y, and this is a 30-degree angle. This is another one of our special triangles. There's only 2 special triangles in the entire world, so here's the other one. In this 30, 60, 90 special right triangle, we know that the short leg is x, the hypotenuse is twice that x, and the longer leg is x times radical 3. So because I'm on the unit circle with a radius of 1, I know that the hypotenuse is 1. That means I know that 2x equals 1, which means x equals 1/2. And if I know x equals 1/2, I know that this side across from the 30 degrees is 1/2. I know that the longer side is going to be x times radical 3. Well, that's 1/2 times radical 3, or radical 3 over 2. So if I go back to this triangle, the side across from the 30 degrees is going to be 1/2. The side adjacent to the 30 degrees, or the longer leg, is going to be radical 3 over 2. So that means that y is 1/2. So I don't need a calculator to tell me that sine of 30 degrees is 1/2. I know it's 1/2. Cosine of 30 degrees, that's x. I know, because this is a special triangle, that x is radical 3 over 2. So I don't need a calculator to tell me that cosine 30 degrees is radical 3 over 2. So this missing point right here is radical 3 over 2, comma, 1/2. Now, again, I want to continue to tell you, listen, you got a calculator, might as well check that I'm right. Cosine of 30 degrees is 0.866, but we know the exact answer is radical 3, make sure you move outside the square root, divided by 2. There it is. There's the exact answer. No other angles other than these special ones will allow this to do. Like for the 136 degrees, that example we did earlier, I could not do this because it's not a special triangle. Sine of 30 degrees is 1/2. I know the value. And then I could also do tangent real quick here. Tangent of 30 degrees, that's the y value, 1/2, divided by the x value, radical 3 over 2. Now, obviously, that's a really ugly answer, so let's clean that up. Let's take the numerator, and instead of dividing, let's multiply by the reciprocal of the denominator, 2 over radical 3. The 2's what we're going to do, so I get 1 over radical 3, which is a beautiful answer, but we prefer not to have a square root denominator. So multiply top and bottom by radical 3, and we get radical 3 over 3 for tangent. Once again, let's just prove that that's right. Tangent of 30 degrees. Boom, there it is, 0.577. But we know that that is exactly radical 3 divided by 3. No other angle can I do this with. So for a 30-degree angle, I definitely expect you to know these exact values for sine, cosine, and now tangent. Now the other angle is a 60-degree angle. Why? This isn't a different triangle. It's the same triangle, just rotated. So once again, this angle of 60 degrees takes me to a point. That point is x comma y. The vertical displacement is the y. The horizontal displacement is the x. And I know that sine of 60 degrees equals that y value over the radius, of course. But if I'm assuming we're on the unit circle, the radius is 1. Please, if you're not on the unit circle, do not panic. All you have to do is multiply that r value over. It's not the end of the world. And cosine of 60 degrees equals the x coordinate divided by the radius, but the radius is 1, so that's just x. But again, I do not need a calculator for this. Go back to our perfect 30, 60, 90 triangle. The longer leg across from the 60 is radical 3 over 2. The shorter leg across from the 30 is the 1/2. Now notice, again, this was based on my radius being 1. If that radius was, say, 5, all you have to do is multiply everything by 5. This becomes 5 radical 3 over 2, and this becomes 5 halves instead of 1 halves. Like, that's not, the end of the world. Whoop, sorry for a second there. So therefore, if I go back to my triangle here, the longer leg, in this case y, is radical 3 over 2, and the shorter leg, in this case x, is the 1 half. There is my sine and my cosine value. Don't even need to calculate to figure it out. And the same thing with tangent. Tangent of 60 degrees is going to be y, radical 3 over 2, divided by x, which is 1 half. Ugly double fraction there, so let's leave the numerator alone, multiply by the reciprocal of the denominator. Those 2's reduce, and I just get radical 3. And I can't emphasize enough, please use the calculator to check me to make sure I'm right. Sine of 60 degrees is that 0.866, which we know is radical 3 over 2. Cosine of 60 degrees is the 1 half. There it is, 1 half. And tangent of 60 degrees is 1.73, but that would be radical 3. Okay, these are the only special angles. Like, listen, 45 degrees, 30 degrees, 60 degrees. Now, I can't let you forget about radians. So in radians, that's pi over 4, pi over 6, and pi over 3. That's just the radian equivalence of those angles. Those are the only special angles. That's it. There's no other ones. It's that simple. So for these angles and these angles only, we should know the exact values. The exact values. Go back to that problem we did earlier with the 136 degrees. I have no choice but to go to my calculator. But if it's a special angle, 45, 30, or 60, I don't have to go to my calculator. I could go to the special triangle, and I can figure out what those missing sides are. Please keep in mind, if the radius is not 1, you just got to multiply it over, not the end of the day, not the end of the world. Okay, so the one other thing I want to emphasize here is reference angles. Remember, a reference angle is the acute positive angle measured to the closest x-axis. So if your reference angle is 45, 30, or 60 degrees, these same values that we're seeing are going to come up again, right? They're going to be the same. The only thing you got to be careful of is what quadrant you're in, because that will determine if x is positive or y is positive. Now, here is what I'm talking about. So here's 150 degrees. You might say, well, 150 degrees, that's not one of my special angles. Yes, but that's 150 degrees to here. The reference angle, this angle right here, would be found by taking 180 degrees. That's the half circle. Subtract 150, that's 30 degrees. So when I make my triangle with the vertical displacement and the horizontal displacement, that's my x and that's my y of this point, I say, oh, yeah, that is a right triangle that is 30, 60, 90. Now, across from the 30 is the short leg, that's the 1 half. The adjacent, that's the longer leg, that's the radical 3 over 2 if you're on a unit circle with a radius of 1. If you're not on a unit circle with a radius 1, all you got to do is multiply those values by the radius. So it's not that difficult. So again, I'm not changing the fact that sine of 150 degrees equals y over 1. Cosine of 150 degrees equals x over the radius of 1. But because the reference angle 450 degrees is one of my perfect, beautiful, special angles, I already know. But here's the only thing I got to keep in mind. I'm in quadrant 2. So that x needs to be negative. That's the only thing. So cosine of 150 degrees, since the reference angle is 30 degrees, that's going to be negative radical 3 over 2. And for sine, that's going to be positive 1 half. So that's how we can incorporate reference angles to expand the 30, 60, 45, the only 3 special right angles. But we can incorporate them to other values that just have those as their reference angles. And I can't emphasize enough. You don't believe me? Go to your calculator. Check this out. Sine of 150 degrees. Look at that. 1 half. Cosine of 150 degrees. Look at that. Right. Oh, negative. Notice the calculator won't lie to you. Negative. And then again, if you're like, wait a minute, is that right? Yeah, radical 3 over 2. That's the 0.866, but it's negative because we're in quadrant 2. So you got to take that into account. So not only do these exact values work for 45, 30, and 60, they also work for any angle that has 30, 45, and 60 as its reference angles. So there are unlimited, infinite points on any circle. We could use sine and cosine to help us find any of those points. If it's one of these special angles, 30, 60, 45, then we can find those values exactly without using a calculator. Otherwise, we will have to use a calculator, for example, the 136 degrees. I got no choice but to go to a calculator to do that. All right, hopefully that makes sense and that we have a better understanding of some of our special angles.